All right, hey students, my engineering, architecture, and design students. This is going to be if you happen to miss it or just need a refresher, the computer lab desk design project. This is the written up document that's actually on Classroom, but I'm going to do a little video walkthrough to hopefully make it a little bit more understandable and walkthrough. So, the background of this, you're familiar with our room. You've been sitting at these desks for the last portion of this whole term. Here's the classroom. I've now been in here for about a year and a little bit more, and my thought is, as a teacher and as a designer, is that this classroom could be a little bit better if we possibly put some more time and thought and effort into the actual design of the desk that you are sitting at currently. This room is what I would call a little bit sterile. All it's really good for is computer work, but there are other cooler things like drawing and doing some other light crafting and prototype work that I'd love to be able to do in this room that these desks don't currently support very well. Just looking at it, all we really got is monitors, a keyboard that's kind of floating on the desk surface, the computer, what I call towers, down inside of this box area down in here. Hopefully that's showing up right. Oop, down looking in there, they're the computer towers. Okay, so pretty simple. But your task is going to be to come up with a redesign of these desks to make them more effective to do more things than just work at a computer all day long. All right. So with that here, I've got the scope of what we're going to be doing. Is you're going to be using common materials that are available in the shop. I'll go over those a little bit more, but some of these things, the way that these are even constructed, are actually some materials that we already have in the shop. And like these the 3D printer carts that I've got here, are great examples that I'll go over of materials that we've already got in the shop here. We'll get to that a little bit more later. That's one thing. You are going to generate hand sketches using that isometric sketching technique we learned the other day when we did Fred. We're going to go through one more exercise before that, but you're going to be generating better concept sketches of what you're going to do. And ultimately you're going to go into SolidWorks and you're going to design all the parts of the desk and then assemble them together, create an assembly drawing again like you did for the castle, but have a little bit more detail on that, and a thing called a bill of material, but we'll talk about that later too, and do all that. But the design of the desk itself, we're going to be emulating the existing height of the desk. These happen to measure at 29 inches tall right now. I'm going to give you a range of between 29 and 30 inches tall from the ground to the top surface of the desk right there. About 29 to 30 inches. That seems doable, like workable. It's worked pretty well. I wouldn't say we have to change that much. Now in terms of the actual working surface, this number 2 here, the working surface, these desks currently are conjoined and they're like 6 feet long. That's 72 inches wide and you got 2 people there. That's cool. But what I'm going to end up thinking about is if we were to break these things into their own desk surface, I'm going to give you up to 36 inches wide here. That would be halfway here, okay? Or down to a minimum, potentially bonus points, if you can save us some space and go down to as little as 32 inches wide here to free up a little bit more floor space in the shop, or in the classroom rather, that would be kind of beneficial. So anyway, the top surface here, between 32 and 36 inches wide, I'm giving you a little bit of a range. And then the depth of this thing, what did I say, 24 inches, these are currently 30 inches deep. I will allow you to stay at that 30 inch potentially, though we may be able to do some things to shrink that down. And extra kudos if you can think about how to make this usable with only down to 24 inches wide that way, or deep I guess I would say there. So you've got a little bit of a range to work with in terms of this volume. The other idea here is going to be that the desk, we're going to have to still maintain storage for these towers in here. We can't do without that. That would be bad, because we still got to have computers to utilize in this class, so we got to come up with that. But I'm telling you that we can even shrink it down. So this is kind of a big cavernous space right here. Look at how much empty, unused space is in there. The towers that we currently have are great. Hopefully in years future, I'm going to have to replace these coming over. Hopefully towers are only going to get smaller and smaller, but I want to have some versatility to go a little bit bigger if I have to. So currently, these towers aren't even that big, but I'm saying I want to be able to accommodate a computer tower that's 6 inches by 14 by 16 in size. And likely we could go look at Dell.com, that's probably where I'd get those. Take a look and see if that's reasonable and what the average size of a tower is. But I want to have a little bit of versatility to go a little bit bigger if I have to in the future. All right. The other thing, we need to have accommodations for the management of the cables and the computer power for the mouse, monitor, keyboard, and networking cable. So if you take a look underneath your desk here, you can even see there's like this thing called a raceway underneath there that helps to manage that, and even a hole punched in that thing right there, so you can actually get cables in and out. We may get crafty in the future and go with wireless connectivity on the computers, which may help a lot, but we still need to have power cables. You can see then that they kind of fish up through here. It's a little bit of a nightmare to deal with that, but that's something that we're going to have to keep in mind with our design, okay? So that's another thing. To optimize the desktop surface, the monitors aren't going to use their existing pedestals, okay? So look at these. These are what I would call the existing pedestals of the monitors. They take up a lot of real estate on the desk, and it's unusable space. It just kind of gobbles space and doesn't do anything good. I want to try and work away from that and free up more desk space to do other cool things. Uh-oh, I got a call. Hold on. All right, I'm back. We got that dealt with. So, where was I? Monitors. Okay. Monitor mounts. I've come up with this crafty method of doing it for the 3D printer carts. And I think there's no reason that we shouldn't just be able to emulate this. I will give you, and we'll work on this, these mounting brackets and everything I've already designed up. I may be kind, I may not, depending on how things go, but I've got the designs drawn out for this already. So we can use this mounting method to undo that, and then I'll go over, this is just some plumbing fittings that allow us to do this. But if you come up with another creative way of doing this, using what would be a little bit more than a 1-inch diameter pipe here, I can give the dimensions on this, go for it. But this mounting method will be available to all of you, and I think we can just simplify on that. Oop, hopefully that's showing up now and there. That right there. All right, so that's the other thing is, yeah, no monitors taking up with big existing pedestals. All right, yeah, and so I don't want those to be mounted on anything larger than a 6 by 6 inch base that could be screwed into the tabletop surface. There must be an accommodation for the mounting of a surge protector. So you can see here in the raceway, if you don't know what a surge protector is, that's an example of a surge protector. You can see down underneath here, it's kind of dark, but there is a surge protector sitting in that raceway right there, okay? So that is a necessity. All right, I can come up with the specs on a particular one that we'd end up buying then. And also, it would be good to have accessibility to that, so we could even plug in something, say, like a soldering iron or a hot glue gun to that as well. But I'll talk about that a little bit more. So, there must be also then, excuse me, space to accommodate these things. 2 pencils, an HB and an HB and a 6H pencil. We've used those before. All right. I want space to then accommodate an eraser, little eraser, and this thing called an eraser shield. Have a spot for those. All right. An Arco, yeah, the T-square, not the pickaxe, but the T-square. We need a space to accommodate this at the desk. We then also need an architect scale. That was these things right here. These triangular things, all right. An adjustable triangle, which we have used. That was our adjustable triangle. And these other things you haven't seen yet, but I hope to get out at each station. This is called a dial caliper. Ooh, dial caliper. And this other thing, these measuring devices, called a micrometer. Ta-da, that's a micrometer. So I'll likely be providing you with solid models of those things so you can see more accurately. So not a big requirement to actually model these things out. We'll have some intrepid student model those sort of accurately to then be able to be brought in, okay? And then again, the last thing, the materials used in construction must be from a stock that we've already readily got here in the shop. And we've got plenty of stuff, and I'll go over the different things, and then different plywood types, so what we'll be dealing with. So that is that project in sort of a wordy nutshell, but that's graphically what I'm going for. So I'm excited to see what you come up with. And yes, at the end, we'll go through and see what everybody's designs are. We may as a class vote each one. And then what I'm really hoping for is that if we come up with some really awesome designs, that second semester here, we may break off at points and actually start prototyping that desk out and allow you all to see something truly come to life that you all have been involved with designing and what it goes into taking to build it. So, and then we could see how it works and see what adjustments we might need to make. And then if things go really right, we'd make 32 of them. and outfit it in a new computer lab space. Cool. So that is that project.